In this video, we are going to see the exterior angle of a circle theorem. Before we see the theorem, let's understand what is an exterior angle. An exterior angle is one with its vertex outside the circle, and its sides are 2 seconds of the circle. A secant is a line that intersects the circle at 2 points. As you can see here in the diagram, each line is crossing the circle in 2 points. Now, whenever you have an exterior angle, there are 2 arcs formed that you can see in red here in the diagram. The larger one is called the major arc, and the smaller one is called the minor arc. It's important to notice that these aren't the only arcs that we have here in the diagram. We also have one above the first line, which is this one that I'm marking in blue. And we also have below the second line over here. But the arcs that we will be using, the major arc and the minor arc, are the ones formed between the 2 lines of the angle. Another important thing to mention is that, as you can see in the definition of an exterior angle, the word secant is marked. That's because the exterior angle is not necessarily always formed by seconds. They can also be tangents. Here we have an exterior angle formed by lines that are tangent to the circle. And in this case, since the lines are only touching the circle at 1 point each, there are only 2 arcs formed, the major arc and the minor arc. We don't have any other arc. So only in this case, when both of the lines of the exterior angle are tangent to the circle, the sum of the major arc plus the minor arc is going to be 360 degrees, which is the complete rotation or the full circle. This is only going to be true when both lines of the exterior angle are tangent to the circle. Now let's see what is the exterior angle of a circle theorem. The theorem says that the measure of an exterior angle of a circle equals half the difference of the measure of the arcs that determine its sides. So the theorem says that angle C, or the exterior angle, is equal to half the difference. So we're going to take half of the difference of the arcs. The difference is a subtraction. It says the difference of the measure of the arcs that determine its sides. So the 2 sides of the angle determine 2 arcs. We have a small one here and the larger one here. The big one is called the major arc, and it's called arc AB in this case, which is the major arc. And the smaller arc is arc DE, the minor arc. To calculate the difference, we need to subtract the major arc minus the minor arc. So it's going to be arc AB minus arc DE. So this formula is going to help us calculate the measure of the exterior angle, knowing the measure of the 2 arcs. You won't always have letters indicating the points like the diagram that we have here. So what we need to remember is the theorem. The exterior angle equals the major arc minus the minor arc over 2. Let's solve our first example. It says find the measure of the exterior angle B. So applying the theorem, it says that the exterior angle, in this case angle B, equals the major arc, the largest arc formed between the 2 seconds, which is 120 degrees, minus the minor arc, the smallest arc formed between the 2 seconds, which is 18 degrees over 2. Angle B equals 120 minus 18 is 102 over 2. And that gives us an answer of 51 degrees. This is how we find the exterior angle, knowing the measures of the major and minor arc. Let's see example 2. In this example, the exterior angle is formed by two tangent lines. We may think that there are missing values because the problem is only giving me the measure of one arc. But if we remember, we only have two arcs here, the red one and the gray one. If we add them, it gives us a complete circle. So that's 360 degrees. So I can determine the measure of the smaller arc by subtracting 236 from 360. So the minor arc is going to be 360 degrees minus 236. And that gives us 124 degrees. Now that we have the measurement of the major and minor arc, we can find the exterior angle C. Angle C equals the major arc, 236 degrees, minus the minor arc, 124 degrees, over 2. That equals 236 minus 124 is 112 over 2. And 112 over 2 is 56. Okay, so angle C equals 56. Oh, see. Angle C equals 56 degrees. Let's solve now example number 3. In this third example, the exterior angle is formed by one secant line and the other one is a tangent. Now, when you have a problem like this, don't make the mistake of using the number that you have outside. That's not an arc determined by the sides of the exterior angle. The exterior angle is angle C, and the arcs that we need are this major arc and this minor arc. But there's a value missing. We need the minor arc. We don't have it. This arc that's not part of the exterior angle measures 200 degrees. And we already know that the complete circle is 360. And since only the minor arc is missing, we can't find the minor arc by subtracting 200 and 102, which is the green arc and the red arc, from 360. So the minor arc equals 360 minus 200 minus 102. And that gives us 58 degrees. Now that we have the major and the minor arcs, we can find angle E by applying the theorem. The exterior angle equals the major arc, 102 degrees, minus the minor arc, 58 degrees, over 2, 44. Over 2 gives us 22 degrees. So angle E equals 22 degrees. Great, now let's see example 4. Okay, in this example it says find the measure of the exterior angle E. Okay, to find the exterior angle we need the major arc and the minor arc. We already have the measurement of the minor arc, 62 degrees. But we need the measure of the major arc, the one that I'm marking in red. But I see that I don't have the measure of the remaining part of the circle. I don't have this measure written down. But if you pay close attention to the diagram, this secant line is passing through the center of the circle. So I already know what's the measure of half of a circle or half of a rotation. That is 180 degrees. Knowing that, I can find the measure of the major arc. the major arc is going to be equal to 360 degrees minus 180 minus 62. And that gives us 118 degrees. And now that we have the measures of both of the arcs, we can find the measure of the exterior angle just by subtracting 118 minus 62 over 2. That equals 118 minus 62 gives us 56 over 2, 28 degrees. So angle E equals 28 degrees. This problem is very similar to the first example that we answered, but now instead of looking for the exterior angle, we are looking for a missing arc. The missing arc is, in this case, the one that's marked with the question mark, is the minor arc. So to find it, we apply the theorem. First, let's substitute the values that we have. The exterior angle equals, but now we have the exterior angle, which is angle B. Instead of writing angle B, I write the value of angle B. The exterior angle, which measures 51 degrees, equals the major arc, which is 120 degrees, minus the minor arc that I don't know how much it is. I will represent it with an x over 2. Now let's clear. 51 times 2 equals 120 minus x. 51 times 2 is 102. That equals 120 minus x. Okay, we keep clearing. 102 minus 120 equals minus x. 102 minus 120 is minus 18 equals minus x. But now I don't want minus x, I need positive x. So I multiply both sides of the equation times minus 1. That would change the signs on both sides. So 18 equals x. Okay, that means that the missing arc is 18 degrees. And this is how it's going to work with any type of exterior angle problem when we are looking for a missing arc. Thank you for watching this video.